Alright, so now let's dive into primitive and non-primitive types and see them in action, see how to implement them, how to execute them, the key differences between the both of them. But before I begin that, I really would like to draw your attention toward the non-primitive types, that we are going to use them furthermore in the future. So if you don't comprehend the full idea behind the non-primitive types, do not really think about it too much, because we are going to expound on them in the future even more. Okay, but before we start implementing them, I would like to add just one small little note to the lesson, which are the comments. The comments are the non-executable part of the code, really, and we use them usually to document our code, to better kind of understand why we have written this code, especially if the code is massive, you know, vast kind of code and too many lines of codes. Then we just like adding these documentation to tell us why are we writing this code, or which part does what, really. Or if you want to give this code to your fellow developer, for example, to fix a problem or to continue building this code, they can understand it just by looking at the documentation. And you can add the single line comment by adding double slashes, and then let's add, for example, anything. You can add the title of this lesson, the primitive and non-primitive types, and you can add multiple line comments by adding slash followed by an asterisk and end it by an asterisk followed by slash, and in between you can type as many lines as you want. Primitive types are integer, float, double, long, character, boolean. Sometimes we add string, but string is really non-primitive types, but we deal with it like a primitive type. Okay, we also have long, character, integer, float. Okay, that's about it, I think. And non-primitive types are like, okay, let's just add like, because this is not all of them. Okay, array, struct, class. What else do we have? String. Okay, so these are some of the examples of non-primitive types. Well, actually, I think I made a mistake, because struct is a value type, so it should be a primitive type. Okay. And we're going to explain the difference between the two types. One of them is reference based and one of them is value based, but don't worry about them too much right now. We're just looking for the simplest explanation of primitive and non-primitive types. Okay, so in order to identify the primitive types, we begin with data type, followed by the variable's name of our choice, and then the value. Okay, and end each line by a semicolon, like age, for example, equals 25. Now, if you try to add 25.5, for example, it won't accept it. It will show you this squiggly red line. If you hover your mouse over this squiggly red line, you can see cannot implicitly convert type double to int. So that means you have to change the integer to double, for example, or float, or you can just adjust this value to be just a fixed number. Okay. All right. So let's add float value to just show you how the fraction works. Let's assume that this is weight equals 37.5, and then by the end of it, if you don't add f, it will show you a squiggly line. So you should end this by a suffix f. All right, and this means like float. This value is float. Okay. You can also add double. Double and float are exactly the same, except that double has a bigger size than float, meaning if you need to add, like, let's assume a very large number, pi, for instance, you can add larger numbers after the decimal point using double than what you can add using float. So let's assume that you're going to add the height equals 173.55. We have character, and the character is just one letter. Grade equals A. Notice that the letter is confined between the two single quotations. Anything between the two single quotations is going to be dealt with as a letter, even if it was special symbol, for example, or even a number. This is not really a number, meaning you cannot do any arithmetic operation on this number, so this will be dealt with as a letter. All right, what else do we have? We have long, population, to add long integers. Let's assume 78 million. All right, we have also boolean is student, and you can add true or false. We also have string, but string is really non-primitive type, but we deal with it like it is a primitive type in C#. Okay, and let's see, name equal double quotations Joan Smith. All right, and now let's display them. In order to display them, we have to write console.writeLine. You can type them fully, or you can just type part of it like this. Okay, and then hit tab and it will continue the line. All right, or you can just type CW, hit tab, and it will finish the line by itself. And in order to present these values, we need to first add like some sort of a string to tell us what this value is, an age, for instance. And then you can add plus an age, and that will combine this string with this value. The plus here is not an arithmetic operation. It's really just to concatenate between the two values, the string and the age. You can choose to do it like this, or you can even do it like this, adding a $sign and then age and then age. Whatever you choose, it's your preference, 100%. I'm just going to choose the first one, really. I'm just going to keep this as an example for you. Wait. Okay. Yeah. All right. And okay, let's change them. We have the height. We have the grade. What else? Population. Notice that C# is a case-sensitive language, meaning if you add a population like this, using uppercase at the beginning, it will show you a squiggly line that says this variable does not exist. And the reason behind that is it has to match the variable's name 100%. So it has like to be a lowercase, exactly the same. Is student is student, and then last but not least the name. All right, now let's debug our application by hitting F5, and then it will show us this screen. No error, of course, otherwise it will show us the error list and we can work on the errors. But right now you can see age 25, weight 73.5, and height, and you can see all the values as well in front of you.